Oop, there it is. Yeah, so hello everyone, and welcome to Red Hat. It's great to have you all working with us for the summer. And also for the returning interns, welcome back. It's good to see so many familiar faces. So like Hema said, so far we've had workshops or sessions on what is operate first and how do you deploy applications on there, and what does the GitOps flow look like, etc. So in this session, we're going to be looking more at the data science aspects of the operate first cluster. And basically, so Michael yesterday talked about what does the data science workflow look like at a high level overview. So today we'll go a little bit into the nitty gritty of like, what are the actual tools available in operate first, and how would you, as a data scientist, use these tools in your day-to-day work. So I guess let's get started. First things first, I'd probably introduce myself. So hi, my name is Karan, and I'm one of the data scientists in the AI Ops team in AICOE. And I was also an intern in 2019, sitting on the other side of the presentation, and then I joined full time. Oindrilla, did you also want to introduce yourself?
Yeah, sure. Hey everyone, I'm Oindrilla Chatterjee, and I also was an intern in 2019, and I joined full time within the same team. I worked for the AICOE as well during my internship, and I joined the AI Ops team as a data scientist. Yeah, it's been pretty fun so far, and I guess we'll be sharing a little bit about what we do and some part of our workflows today with you guys.
Cool. Yeah, so today in this session, we're gonna talk about how do you get started with Jupyter Hub, which is gonna be your best friend during your internship. And then some handy tips and like things where you can ask for help, etc. And then finally, Oindrilla will talk about how you can deploy your notebooks in a pipeline fashion and how you can automate the workflow, and basically elaborate on the things that Francesco mentioned in yesterday's session. All right, so let's get started. So first things first, how do you access Jupyter Hub? So to access the Jupyter Hub console, you can go to operate-first.cloud, then click on users. And then there you should see a link for the Open Data Hub dashboard, the ODH dashboard. So go ahead and click on that link. And this dashboard basically shows what are all the applications that are already deployed on the MOC cluster. And for the most part, at least for the beginning of your internship, you'll only be probably using Jupyter Hub. So go ahead and click launch. And that'll bring you to, well, that'll actually bring you to a sign-in page. So you can just click on MOC single sign-on and then sign into the Jupyter Hub. I was already signed in, so it didn't ask me to do it, but yeah. So once that is done, you should see a page that sort of looks like this. And this is where you will configure what your working environment would look like. So for example, one of the things here is container size. So here's where you can select like how many CPU cores and like how many gigs of RAM would you need in your environment. So if I'm working on something small, maybe just some visualizations or some small notebooks, that I should be good with just 2 cores of CPU and 2 gigs of RAM. But also if you're working on some super large data set or some super heavy model, you can also go ahead and select large memory intensive container size, which is like 8 cores of CPU and 32 gigs of RAM. For now, I'll just stick with the small container size. And the other thing to configure here is the notebook image. So here you'll see like a list of all the available container images that you can spawn your environment with. And well, I'm sure people have already told you like 50 times what an image is, but I'm still gonna go ahead and tell you a 51st time what an image is and why we do it. So yeah, so all the things, all the list of items on here, each one of them is basically a notebook image. And what an image is basically like a pre-packaged set of system libraries, packages, some binaries, and etc. So for example, the TensorFlow image would have like NumPy, SciPy, and TensorFlow pre-installed, as well as all the matrix multiplication libraries and other system libraries that TensorFlow requires. So once that image is spawned, then you don't really have to do any other setup, and you can just directly go import TensorFlow STF and then start data sciencing away. So that's basically what the image is. So similarly, you might have other images like a PyTorch image. So the PyTorch image would have NumPy, SciPy, PyTorch installed, and then some other libraries that are related to PyTorch and optimized for PyTorch. So that's what basically a notebook image is. So if you know that you're working on a project where you'll need TensorFlow, then go ahead and select TensorFlow image and work in that environment. Or if you know that you're going to be working with just scikit-learn, then you can just select a scikit-learn environment and work with that. So yeah, so in addition to these Python package-oriented notebook images, we also have like project-oriented notebook images. So these are things like categorical encoding or Ceph drive failure prediction or OpenShift CI analysis. So what these images are basically all the requirements and dependencies for that particular project, as well as the source code itself for the project. So the OpenShift CI analysis image would have all the dependencies for the OpenShift CI analysis project. So that's these things. As well as it will already come with all the notebooks and all the source code and everything pre-installed in the image for you to work on. So yeah, actually, let me hit start and go ahead and spawn a pod with that image. While that's loading, so yeah, so we can also have images with source code itself pre-baked into the image. And one of the things is like, why would you want to use images? Like, why do we have this setup? Is so there's a couple of benefits. So one of it is reproducibility. So if I'm using the TensorFlow image and I'm training a model and I'm making some predictions, so then when I share that code with you, then when you run it on the same image, then you should have the same exact model weights and the same exact predictions for your model. So this enables us to have like this complete 100% reproducibility. So that's one of the benefits. The other is like easy shareability. So by that I mean, like I showed, like if I want to show someone that what the OpenShift CI analysis project is, then I don't need to tell them to clone the repo and then set up the environment and install dependencies or anything. I don't need to do that. I can just tell them to go to the Jupyter Hub and then select the OCP CI analysis image and click on start. And that's it. That's all they need to do. And then they'll be able to look at the work that we have done. So this enables us to have this really easy sharing of work. And finally, it also allows for modularity, which is like, instead of having one bloated giant environment with all the dependencies installed, like TensorFlow, PyTorch, stats models, scikit-learn, etc. So instead of doing that, you can just have like these separate images and then pull the images according to what you want to work on. Yeah, so like, I mean, these are just some of the benefits. I'm sure this is not an exhaustive set, but these are some things that are obvious to me as a data scientist. And let's see if it loaded. Okay, perfect. So when the Jupyter Hub spawns up, it should look something like this. And I haven't checked the polls. I don't know if people have used Jupyter Lab before, but this is essentially a Jupyter Lab environment. So on the left-hand side panel, what you have is your home directory. So these are all the folders and all the notebooks that I have in my home directory. And on the right-hand side, you have this launcher panel. So from here, you can click on Python 3 notebook to start a Python 3 notebook, or you can start an interactive console or an LRI pipeline, like Oindrilla will show later on, or start a terminal, etc. So yeah, so to get started with the projects, your projects will probably going to be hosted on GitHub. So the first thing you'll need to do is to clone the project. So for that, you can go ahead and click on terminal, and then go to the directory where you're going to clone the project, and then just do a git clone. Let me actually increase the size. Okay, let me know if you cannot read it, but I hope this should be big enough. But yeah, so you can just do a git clone, and then whatever project you want to work on. So for my case, it already exists here, so it's not going to show me, it's not going to clone again. But yeah, once it's cloned, you can just click on you can just navigate through this panel on the left, and then start working on whatever notebook you want to work on. Also, if you feel uncomfortable using the terminal or something, then you can also use the Git Plugin, which is the third icon on here, to clone a repo and then, yeah, get all the files for that repo. So let me actually open up this notebook. Yeah, so before I start going to the notebook, I just wanted to mention a few things. So a lot of the images in Jupyter Hub come preloaded with a lot of useful extensions. So for example, you have a Git extension. So this lets you do an easy diff of the notebooks. So let's say I change something over here. Okay, and then if I wanna contribute this back to the repo, and I wanna see what are the changes I made, usually what I would do is do a git status and then do a git diff on the notebook. But because of the way that the notebooks are set up, it's essentially like a JSON blog. So it doesn't let you, it's sort of unclear what these things mean. So that's where like these plugins kind of help you be more productive in your workflow. So here you can, so the Git plugin should be like a button over here on the top. So you can just click on the plugin and see in a human-friendly, understandable way that what are the things that you changed in this notebook, and what are the things that other people changed, and what do you need to do to rebase your stuff. So yeah, you have some useful plugins over here. Another useful plugin that I think Francesco also mentioned yesterday is the Jupyter Lab requirements. So this is a plugin created by the Thoth team to, and it lets you get the most optimal set of dependencies for your notebook. So to use this, you can click on the Manage Dependencies tab on here, and it will show up this pop-up dialog box. And here, basically, you can add whatever Python packages you want for your notebook, and click on Save and click on Install. And that will basically contact Thoth and set up the requirements and also install those requirements. So I actually don't need those, so I will go ahead and cancel this. But yeah, that's another useful plugin that you should use in your workflow. Another thing is the resource usage. So that's the little message down here that says mem 366 out of 2048 megabytes. So that basically lets you monitor the resource usage for your Jupyter Hub pod. So I'm just going to go ahead and try to run some of these cells. Just shift enter, shift enter, shift enter. And yeah, so basically here you can see in live that how your memory is being updated as the code runs. So this is super useful to have because so as you can see, like this is a pretty large array, so it might probably crash and not really load up all the way. And let's see. So yeah, while you can also look at this here, it's not really a super user-friendly dashboard kind of a thing. So you can also look at the other monitoring tools that we have set up. So yeah, so when things don't work, or when you feel like you want to monitor what stuff, how many resources you're using, the place where you can check that out is the Grafana dashboards. So it'll ask you to log in with MOC, single sign-on. And yeah, that will bring you to this Grafana dashboard that is hosted on the MOC cluster. And here, basically, you can set on the top left corner, you can set your user ID. And then the rest of this would show you the CPU usage, the memory usage, and so on and so forth for your particular Jupyter Hub instance. So here I can see that I've used 5.4 gigabytes of my storage space. And then, oh, by the way, this crashed. So yeah, not a surprise. But yeah, so when things like that happen, don't panic. It's okay. Things crash all the time. And to try to understand what went wrong, you can use these Grafana dashboards. So here, I can see that my notebook usage, oh, where is it? Yeah, so my notebook CPU usage was about 30%. So that's not too bad. That's probably not an issue. And then in memory, I can see that there was sort of a spike in memory, or like a bunch of spikes in the memory. And that's where it flatlined out. So that gives us some hint that probably the issue with the kernel crash was the memory usage of my pod. So yeah, that's how we use the Grafana dashboard. And again, if it's not entirely clear from the dashboard that what's wrong, there's also a bunch of other resources. For example, you have a Jupyter Runbooks setup. So this is essentially a troubleshooting doc. And here you have, like our SRE team has listed out some of the common problems that you might encounter while using Jupyter Hub. So for example, one of the things that you might run into is insufficient disk space. So this doc literally describes that like these are the steps you can follow to see if you have actually, in fact, used up your storage. And then if you have used up the storage, then it'll tell you these are the steps that you can follow to increase your PVC size. So if you click on this link, yeah, it'll take you to these docs where it tells you that, hey, as a data scientist, I want to increase my storage space. So how would I do it? So yeah, so this is the scenario that will be set up. Like you'll request PVC storage, and then these are the steps that you'll do. So yeah, so you have this nice troubleshooting doc set up, and not all of the things here would be directly relevant to you as a data scientist, but still it's worth checking out the doc before yeah, reaching out for help. That said, you can always reach out for help in the Slack channel. So this will take you to the Operate First Slack. Actually, I'll show you the one that I'm already logged in. So yeah, so this is the Operate First Slack channel. And if you run into any issues, feel free to ask in the support channel. Oop, it locked me out. But yeah, but if you ask in the support channel, someone from our team would answer you like within minutes, if not within seconds, actually. So it's super cool. Our SRE team is great. So that's where you can ask for support. And if for some reason you do not want to use Slack, or I don't know, Slack is down or something, you also have the operate first support repository. So this is where you can basically open issues to ask for things like, so if you need some S3 storage, if you need an S3 bucket, you can open an issue with that here. Or if you need more CPU that one of the container sizes doesn't have, you can ask over here. Or if you just have some generic question about operate first, you can also open issues over here for that. So yeah, so one of these four should always be able to resolve whatever issue you're running into. And yeah, you should be good to go from there. And I think that is all. I mean, we don't have a lot of time, so I'm not going to go into some of the other neat tricks and neat tools that you have. So this is not really operate first related, but these are just some of the handy things that I feel like every data scientist should have in their tool belt, and it will probably help you be more productive. So, but we don't have time, so I won't go into like what a debugger is or what a profiler is, etc. But if you're interested, you can always check out the Python Data Science Handbook, which is an open source handbook of tips and tricks that will help you be more productive. But yeah, that's it. So with that, that's the end of this session. And now I think Oindrilla would go ahead and talk about how you can use Illyria pipelines to automate your workflows. So take it away, Oindrilla.
Awesome. Thank you, Karan. I will be sharing my screen here.
Yes, let me stop sharing. There you go.
Awesome. Is my screen visible? Do you see the slide?
Yes.
Yes. Okay, perfect. I do not have a lot of slides, so I'm just going to keep it minimized here. So I think most of you, I'm guessing most of you already attended the Illyria and AI DevSecOps workshop yesterday by Francesco. So this is just going to be a more specific use case of that, and I'm just going to show how we used the whole Illyria and Kubeflow Pipelines editor for one of our projects. So like how Karan mentioned, we use the Jupyter Hub or the Jupyter Lab environments for most of our projects. And for some of our data science projects, we perform all parts of the machine learning workflow within Jupyter Hub, like starting from the data collection to data wrangling, exploratory data analysis, machine learning modeling, and all parts within notebooks. So there comes the need of automating some of our workflows. So sometimes we have created notebooks which always run in sequence, one after the other, and we need to automate that whole pipeline and remove all the manual effort from it, and make sure that we are able to trigger the whole sequential set of notebooks in a regular automated fashion. So basically, for that purpose, we have been leveraging some of the neat tools set up for us, which is Kubeflow Pipelines and Illyria, Jupyter Hub extension for some of our workflows. So basically, why we have been using Illyria and Kubeflow is because we need sequential and continuous running of our machine learning workflows. And using Illyria, which is basically a Jupyter Lab notebook editor, and it's also an extension which comes with Jupyter Lab. Using that, we can create and run our notebooks on Kubeflow Pipelines. And what is Kubeflow Pipelines? It's basically a platform which can be used for building and deploying scalable machine learning workflows. So luckily for our use, we already have a Kubeflow Pipelines instance available in Operate First. So if you must already have access to this Operate hyphen first.cloud website. You could go to users and Kubeflow, and in order to access Kubeflow Pipelines, you'd find the UI and the API endpoint right here. So this will take you to the deployed instance. Now, in this example today, I'm going to be showing how we created a sample Kubeflow workflow using the AI for continuous integration project as an example. So that's one of the first projects we used this for. And so coming back to the presentation slides, coming to some prerequisites that we need in order to run the pipeline. So the first thing is you must have the Elira extension within Jupyter Hub or within Jupyter Lab. And we already have that on the MOC Jupyter Lab, the Mass Open Cloud instance, which you can find on this link, or also you can navigate through from the Operate First website. And you would launch the Elira 0.0.8 image. So if I go to this URL, it will take me, since I have already launched Jupyter Lab, it's going to take me to my workspace where I can access, which basically shows what's in my PVC, and I can access the functionalities of Jupyter Lab. But if you were launching it yourself, you would just need to log in using your Google credentials. And once you have done that, you would just want to launch the Elira version 8 image, and that will make sure that Elira extension is installed within your Jupyter Lab. And for Kubeflow pipelines, you could simply access it from this URL, which I showed. And the third prerequisite that we have is how you need to format your project and the considerations that you need to have within your notebooks and your project in order to make sure that your notebooks are can be automated using Kubeflow pipelines. And I'll come to that a little bit later. I'll show how we did it for our project. So, so firstly, to access the Elira UI, I would launch it from Jupyter Lab, the version 8. Then one could simply clone any repository which one wants to automate. So here I have already cloned the OCP-CI analysis project, which is one of our AIOps projects. And here in this project, we are working with we are performing different machine learning, and we are applying AI to a lot of open source CI data. So in this project, we have different parts of a machine learning workflow. We have different notebooks which look at this open source data collection, some data wrangling, metric collection, machine learning workflows, and we wanted to run all of these parts of the workflow in a pipeline. So firstly, we want to make sure that we have tagged a new release for the project using the AICOE pipeline. So as Harshad mentioned before this morning, using ThoughtBots and the AICOE CI tooling, it's very easy to tag a new release for any project. So if I were to tag a new release for the OCP-CI project, I just would need to open an issue in the project, and I can show an example of this here. In order to make sure that we have an image which contains the project-wide dependencies, we need to tag a new release for the project. And that's as simple as creating an issue in the project's GitHub repository, and you can go like, hey, AICOE CI, please build and deliver the Git tag, and the AICOE CI and the Sesheta bot will make sure that a new release has been tagged and it's available on the project's Quay registry. And we have already done this for our project, as you can see, using this issue, and we can find the created project image on the project's Quay registry. So, so in this Elira pipelines and Elira and Kubeflow pipelines, we'll simply be using this image that we created. And in order to actually add this image that we have created on and which is available on the registry to the Elira metadata, we can use both the command line or the UI. And I find it way simpler to use the command line here. And I'm going to explain what the command is. And there's also documentation which lists all of this. So I'm just going to go over it really quickly. So as you can see here in this Elira metadata install command, I'm just providing a name, a display name for the image that I want to add. I'm providing a description, and I'm providing the link to the Quay image that we just created using the AICOE pipeline. So yeah, and so now we can see that this latest image has been written on to the Elira metadata. And next, what we need to do is we need to create a runtime which can be used in the Kubeflow pipeline. And basically, I think Francesca already explained this, but I'm just going to quickly go over this step. So this basically ensures that the Elira is actually Elira and Kubeflow is actually connected to the bucket where we are storing all the information, and we are also going to provide the API endpoint to Kubeflow here. So just to quickly go over this, I will also use the command line for this step and explain it in brief what we are doing here. So in this Elira metadata install runtimes command, we are making sure that we provide the API endpoint to Kubeflow, which I just earlier navigated through from the Operate First website. We are providing a display name for this pipeline, which we want to create. And I'm providing the schema name as KFP, which stands for Kubeflow Pipelines. And the engine can be, like Francesco mentioned, Argo or Tecton. We are using Tecton here. And the remaining credentials that you see are bucket credentials, like the bucket endpoint, username, password, the bucket name. So bucket is basically a place where we are storing. It's a storage for where we push our metrics to, where we download and save the data to. So this is a public bucket, which we are using for our project. But if you're using private bucket credentials, you need to follow some additional steps, like you need to make sure you create a Kubernetes secret within your user namespace. And you'll find more information about this within the documentation itself. So yeah, so I essentially used and provided some public bucket credentials, which has been assigned for this project in here. And you could also request a public bucket for your own project. And you can easily provide the credentials here. So once this metadata instance has been created, once we have created the runtime, we will now move on to the next step, which I find more visually fascinating, better than writing certain command line steps. So we will now try to create a new Elira visual editor. So in order to do that, we'll go to a new pipeline editor. And essentially, in this new pipeline, we can drag and drop any notebooks which we want to add, which we want to run sequentially, which we want to make a pipeline for. So for this project, we have a couple of notebooks which we want to run in sequence. So one of those is the get raw data notebook. So what this notebook is essentially doing is it's connecting to a public endpoint from which we want to download the test grid CI data. So we are essentially downloading some data from that endpoint, and we are storing it into the S3 bucket. And in order to make sure that the notebook is actually connecting to the S3 bucket, we are making sure that we are configuring the environment variables here. And I'll talk more about how the notebook is actually fetching these environment variables in the next while I'm explaining how to create a pipeline. But basically, this is the first step of our pipeline. We are just fetching the data and storing all this data onto an S3 bucket. And the next step is some metric calculation, which is basically, you can think of it as a step where we are fetching the raw data which we previously stored into S3, and we are doing some metric calculations, and we store back these calculated metrics onto the S3 bucket. So here we fetch some raw data, perform metric calculations, visualize them, and store them back onto S3. So let's say I want to automate these two notebooks in sequence. So I'm going to drag and drop these two notebooks here. You can connect them by just using these output and input ports here. And we can also, let me see, where did I create this pipeline? So we can also save this pipeline first to any given name that you want. So it's currently called Untitled Pipeline, but depending on where I created this, I should be able to rename this. Okay, so it's here, so I can just rename it to let's say demo pipeline. And yeah, so now we have a couple of notebooks which we want to run in sequence. And now by clicking on these three dots here, we can make sure we add certain notebook properties. And these notebook properties are essentially parameters like the image runtime, the environment variables, the resources which a certain notebook needs in order to run within the Kubeflow pipeline. So I will add the runtime image that we previously created on the command line, which is the OCP-CI project workflow. And I'm going to provide some CPU and RAM requirements depending on what that particular notebook needs. So I'll provide 1 CPU, 8 gigs of RAM, and file dependencies are basically any utility notebooks or any other dependencies on Python files or other notebooks which this notebook depends on. So some of our notebooks, they are dependent on a metric template notebook for template functions, utility functions. So you can basically add your file dependencies here. So I'm going to select the metric template notebook here. And also, one needs to be able to provide the S3 endpoint credentials here. So as I mentioned previously, this is basically how the notebook is communicating with the S3. We are configuring the environment variables for the notebook in here. So this is basically from where the notebook can get the values for the S3 endpoint within these cells. So I will provide the access key, the endpoint, and all those credentials here. So apart from the S3 bucket credentials, as you may have noticed, I'm also providing an in-automation flag. So this in-automation flag is another notebook prerequisite. This makes sure I will pop back into the notebook. So as you can see, we are configuring an in-automation flag within each notebook. So this makes sure that whenever a notebook, whenever this environment variable is configured true, whenever we want to run the notebook in automation, we'll configure this environment variable as true, and that will make sure that the notebook is able to connect to Ceph and get the data from Ceph and not run locally. So these flags basically will ensure that our notebooks are communicating directly from the S3 bucket and not locally. So the couple of prerequisites that I mentioned in the slide for the project and notebook formatting are basically this, that we need to make sure that we are configuring our S3 credentials for the notebooks to run, that the data should be read and write to and from an S3 bucket. And we also need to configure these automation flags. And apart from that, basically that is really it. And you can configure your project or any notebook in any format into a format suitable for running Kubeflow pipelines. So yes, so these are the properties that I needed to add here. And you could do the same for every notebook in your pipeline. So I have already done this for our project notebooks. So I'm going to directly open the already created pipeline. So as you can see here, all these notebooks, as I hover over it, you could see that we have already configured the environment variables, all the credentials for each notebook. We have done this for every metric calculation notebook. And we can simply, in order to make sure that everything is running perfectly, we can just trigger a test run. So once you have created all of those, you need to save the pipeline and hit trigger. So yes, so once you hit the play or the run button on the top left, I could call it a demo pipeline, or give it any name you really want. Select the runtime which we previously created, the runtime configuration, OCPCI metrics, and you can hit OK. Yes, so as you can see, the job was successfully submitted. And in order to just inspect and see what's going on and make sure that the run is working as expected, you can check the status of your job by going to the run details from here. And this basically takes you to the particular experiment or the run that you just triggered. And for each notebook in the pipeline, you should be able to see a rectangular box here. And there's a rectangular box for every step of the pipeline. So once you click on it, you should be able to go to the logs tab. And here you should be able to see any logs that the notebook is generating. And this generally helps debug anything that went wrong while running the notebook, anything that failed, any thing that's unexpected. So this is how I would investigate any issues happening while running of that particular step. And yeah, so this typically will take a little bit of time depending on how compute intensive your step is. But in order to see how it should look after running all of the pipeline, after the whole pipeline completes, let's see a demo pipeline. So this is how it typically looks, where there should be a green check mark next to that particular step. And you should be able to make sure that everything ran successfully. So for us, what we did in order to make sure that everything is actually run successfully as a sanity check mechanism, we just created a utility notebook within the repository called Validate Pipeline, which is basically just connecting to the S3 bucket and displaying what are the current files that you're storing within the S3 bucket. So when I run this notebook, I should be able to see what are the contents of the S3 bucket for today. So for example, as I scroll below here, if I have to check today's data on S3. I should be able to see all the metric files that were stored into the S3 bucket after the pipeline successfully ran. So I see that I have all these files which are dated for today. And we also have the raw data that we stored in the first step. So this is a sanity check method for us to just make sure that the pipeline ran successfully. And you could do the same for your own project. And yeah, this basically brings me to the end of this short demo. And I will also share some links to some tutorials which we created, just adapting the whole Kubeflow, Francesco's Kubeflow and Elira workshop for our project. We'll share some of these. We'll also share these slide decks, so you'll have access to all the endpoints, these instructions for how you need to format your notebook and your projects. And yeah, that is basically it. And please feel free to reach out to me either on chat or email, or even now. Please let us know if you have any questions.
Thank you, Karan. Thank you, Oindrilla. Do we have any questions for them? And I hope you guys also had a chance to answer the polls. We had a few questions for you. I did see quite a few responses, so thank you for adding in your votes. All right, I do not see any questions, but thank you once again for joining. And we will be having 2 last sessions for the day, and then you guys will be free from the boot camp. So I will see you later this afternoon. I think we have a 30-minute gap right now. So yeah, we'll see you guys back there. And thanks once again, Oindrilla and Karan.
Thank you all.
All right, bye all.
Bye.